Astro.
Hi guys, for this video I will discuss sources of supply in series or parallel connection. Power source can be a batteries, generators or other forms or types of voltage supply. It is needed to connect power sources in series or parallel connection to deliver enough power to one or more loads. So for the series connected sources, the number one condition for this is that the total voltage is equal to the algebraic sum of the individual voltages. If the voltages are the same, we can say that the total voltage E sub T is equal to N multiplied by E, where N is the number of individual voltage source, and E is the value of voltage. For other video guys I will going to discuss series aiding and series opposing of battery source. So stay tuned for my next video. I will also set some examples for that. Then next guys is that the currents and power delivered by the individual unit are equal. Just remember guys my discussion about series connected resistor that the current flowing in series circuit is the same. In power guys, the power delivered by each of the sources are also equal. So meaning, P total of series sources, P sub T is equal to N multiplied by P since they are equal. Then we go now for parallel connected sources. For the number one condition, we have to know that the terminal voltage of the combined sources is the same as that of the single unit. E sub T is equal to E, where E sub T is the total voltage, while E is the individual voltage. Second condition is that the current delivered by the individual unit are equal. I is equal to I sub T divided by N, where I is the individual current, N is the number of sources, and I sub T is the total current. But if you want to solve for the total current I sub T, you just simply multiply the value individual current to number of sources. Then lastly guys is the power delivered by the individual units are equal. So we will use P is equal to P sub T divided by N, where P is the individual power of the source, N is the number of sources and P sub T is the total power, just like the series connected sources. The total power of parallel connected sources can also be solved by P sub T is equal to N multiplied by P. Okay guys, we go now to the examples. A group of 12 similar dry cells, each one having EMF of 1.5 volts, is connected in parallel series as shown in the image. If load resistance of 0.4 ohms is connected across the combined sources, determine the following, neglecting the internal resistance of the cells. A. The total load voltage, current and power. B. The current and power delivered by each cell. The solution guys is the total voltage E sub T is equal to 4 times E. Since the number of voltage connected in series is 4. So E sub T is equal to 4 multiplied by 1.5 which result into 6 volts. The total voltage for the circuit is equal to 6 volts. Why 6 volts? It is because the terminal voltage of the combined sources is the same as that of a single unit. Next guys is the total current flowing in the load, so the solution is I sub T is equal to E sub T divided by resistance load R, where E sub T is equal to 6 volt, and R load is equal to 0.4 ohms. So I total is equal to 6 volts divided 0.4, which will result to 15 amperes. And then for the total power delivered by the load, P sub T is equal to E sub T times I sub T, where E sub T is equal to 6 volts, and I sub T is equal to 15 amperes, so P sub T is equal to 6 volts times 15 amperes, which will result into 90 watts. We go now for question B, which is the current and power delivered by each cell. So I cell is equal to I sub T, divided by N, where I sub T is the total current. N is the number of sources in parallel, so I cell is equal to 15 amperes divided by 3. That will result to 5 amperes, meaning 5 amperes is flowing in each branch of the sources. Lastly guys is the power in each cell can be solved by P cell is equal to E times I cell, so substituting the given P cell is equal to 1.5 volts times 5 amperes, that will result to 7.5 watts. Another way to solve for P cell is equal to P sub T divided by N, where P sub T is the total power, and N is the number of voltage sources. So P cell is equal to 90 divided by 12, which is equal to 7.5 watts. So as summary guys, for series sources, number 1, total voltage. E sub t is equal to N multiplied by E. Number 2, total current, I sub t is equal to individual current I. Number 3, total power delivered, P sub t is equal to N multiplied by P. For parallel sources, number 1, terminal voltage is equal to single unit E. Number 2, total current delivered, I sub t is equal to N multiplied by individual current I. Number 3, total power delivered, P sub t is equal to N multiplied by P.
Hey guys, thank you for watching. See you on my next vlog. Please don't forget to like, share, and subscribe for more videos.